Good morning. My name is Raj. My teammates and I will be presenting our project. My teammates' names are Iskandar and Imran. My supervisor's name is Aminah.
This is our project name, Smart Motion Flash. And this is table content about our slide Viva. Okay, I'm going to introduce the introduction. Okay, the introduction. Current of our project is closely tied to current state of world. Malaysia and the rest of the world is currently one of the biggest pandemic in history, COVID-19. Okay, in this social distances and constant need to sanitize our hand where avoiding physical contact is necessary. Public restroom is one of the most visited places by the general public. Instead, restroom is the risk of contracting the virus is high because of the lack of automatic flush system, since people will need to physically touch the button in standard toilet and expose themselves. Okay, this project main is to solve this issue that can possibly have big impact in reducing the spread of the virus. This project is called Smart Motion Flush, an automatic renal flush device that function and use ultrasonic motion detecting, which allow user to flush the urinal without any direct involvement and contact. It will detect a person standing in front of the urinal and trigger the flush after they are moving away and go back to standard by mode and ready to use again. It functions using battery power, so there is no need to wire power supply, allowing it to easily install and use anywhere restroom as a urinal. Next. Okay, problem statement. First, due is the high cost, the lack of automatic runner that function using sensor in public restroom of nation. Some automatic flushing system do exist in the market, but they are too expensive. They are too complex construction. Second, no need to physical touch button in restroom and exposing ourselves to the risk. Contracting the virus does need to reduce the risk. Third and final, wastage of water from older type of urinal, which are constant running water that doesn't stop in order to flush. Next.
This is objective of project. First, develop an automatic urinal flush that was using ultrasonic wave technology, which can be installed in public restroom for much lower cost compared to those available on the market, to allow mass adoption of the system. Second, remove the need to directly touch flush button or lever, so that the risk of contracting the disease decrease using this touchless system. Third, save the amount of water being used to flush urinal by developing a water efficient with a ultimate flushing system. Scope project. User scope consists of two male user that use main restroom with urinals. Third, men's restroom in INNOCOM Polytechnic for case study. System scope for the software. Arduino Uno IDE software using C++ language. For an hardware, use ultrasonic sensor technology to function automatically without physical contact. When users stand in front of the urinals, the sensor will sense the presence of the user. LED light, red and green color are also present on the ultimate flush device, indicate the activation of the flushing and standby mode. Project efficient. First, to design a device that help to reduce physical contact during this COVID-19 pandemic. Second, to develop an ultimate urinal that improve convenience for the user with a seamless system. Third, to decrease the amount of water being wasted to flush by using all the standard urinals. Fourth, to provide a cheaper automatic urinal flush to replace all the urinal as an alternative.
Now I will explain the literature review. The literature review is in table form and it comprises of three previous projects and our current project. They are divided into 4 categories based on the touchlessness, the cost, the sensor or technology used, and the water usage value. For touchlessness, only one project, which is the third one, has minimal interaction. All the others are completely touchless. And for the cost, there is a big difference between the first project, which costs over 800 ringgit, and the second one, which costs 106 ringgit. The third one also has a high cost, but the specific cost is not stated. It is based on the material use. The cost has been deducted. The fourth one is our project, which has the lowest cost of 89 ringgit 50 cents. And technology used varies from the Delta PLC technology used in the first one, and ultrasonic sensor and Q2 gas sensor for the second project, hydraulics for the third project, and our project uses the ultrasonic sensor. For water usage volume, the first one uses 500 to 900 milliliters, which is quite low. The second one is slightly higher at 400 to 1,000 milliliters. The third one is the highest at 700 to 1,100 milliliters average. And ours is the lowest, using only 200 to 500 milliliters. Based on the data collected, it can be concluded that our project excels at water usage efficiency, and it has the lowest cost of production. Where it compromises in features, it makes up in ease of use and functionality with no drawbacks in quality. Next. This is the cost planning of all the hardware we use to create the project. The total cost is 89 ringgit 50 cents, and the hardware used range from the Arduino Nano, terminal breakout board, ultrasonic sensor, red and green LEDs, resistor, a donut board, a relay module, batteries and battery clippers, solenoid valve, wire, and 3 things for waterproofing the device: waterproof enclosure box, waterproof socket joint, and epoxy glue. Next. The demonstration of the project will be at the end of the PowerPoint presentation.
Okay, as a conclusion of project, with this project, we can hope we can create function and practical automatic renal flush with a low production and sale cost that can be adapted and used commercially in every public restroom to control the spread of the virus and maintain the hygienic level required to keep everyone safe from COVID-19. Okay, thank you. Now we're going to present our project.
Hello, my name is Raj. Now I will demonstrate our project. This is the solenoid, the smart motion flush device itself, connected to the solenoid. This is the water inlet valve, and that is the DIY urinal model for the demonstration. Now to demonstrate the activation of the device. The red LED indicates standby mode, but when the sensor is covered, it flashes green. Then it goes solid green, indicating the flush is ready. When the user walks away, it will start flashing red and starts flushing and goes back into standby mode.